Assalamu alaikum. Hello everyone. My name is Lamar Hadi from section 4 of the Communication Principle course. Today me and my friends of group 13 we will talk about the radio digital modulation. So when you think of radio, have you ever thought about how does the sound come off a radio? I'll briefly explain how. So when you talk, there's a vibration that goes in the air. So when you talk into a microphone, that microphone takes that vibration and turns it into an electrical energy. So it goes through the radio. But we need something for it to through the radio. This is where we use a high frequency carrier wave. So this wave goes through the modulation process and then it sends it as a digital data. So we will cover how to understand the core concept of radio digital modulation and amplitude shift key, identify the key benefit and cite real-world uses, and highlight the main weaknesses and address radio safely. So in order to understand the process more, we need to understand what is modulation. Modulation is actually the process of carrying one or more property like an amplitude, frequency, or phase into a carrier, high frequency carrier signals, which carries the information with it. So the radio digital modulation is the same process except that it turns that information signal into digital data, so into ones and zeros. So the amplitude shift key, which also is an on and off key, it's called that because when the pulse rate is high, that means the carrier is on, and when the pulse rate is low, the carrier signal is off. So the main properties into the process, the digital data stream, which takes that information and then it sends it to the carrier wave of ones and zeros. So that carrier wave takes the message to the ASK signals and it encodes it into as a message. So when sending anything, there has to be a transmitter and a receiver. So we will start from the transmitter, which has a modulator which acts as an on and off switch for the digital data. So the modulator turns on when the digital data is 1, and then it carries on through the signal, but it turns off when the digital data is 0, and it blocks that signal. As you can see in the image, the 1 makes a wave, but the 0 does not. Then the signal is proceeded and sent through the antenna to make a radio wave. After that, the signal is sent through the air where it can be weakened or distorted by noise, and then the receiver's job is demodulating the signal into the originals, ones and zeros. So there is two ways where the receiver can take in the message, which is an envelope detector and a coherent detector. So the envelope detector is very cheap and simple. And how does it work? It's that it checks the signal's energy against a threshold. If the energy is above the threshold, it makes a 1. If it's not, it makes a 0. But the coherent detector is actually way more accurate, but it's complex because it takes the perfect copy of the carrier wave and then it makes it into the noise. Since the ASK code encodes information in the signal strength, that makes it very sensitive to noise. That's why we need something to be able to measure the noise width, which is what we call bit error rate. So what it is, we measure the performance using the bit error rate, which is the percentage of bits flipped by noise. So in order to find that noise for the noise to be accurate, we need a high signal to noise ratio, which is actually expressed as the EB over the NO. So this image here actually concludes all the process and it makes it very visual in order for everyone to understand it. So in order to really understand the concept, we have a small game which needs two people. So the one of the people has to be the transmitter and the signal. So the transmitter will get a code and they will form it into 4-bit numbers, and they will have to send that code by the flashlight. So when the bit number is 1, they turn the flashlight on, and when it's 0, they turn it off. And the transmitter has to take these numbers and to form a code.
Assalamualaikum warahmatullahi wabarakatuh. My name is Misha Soni. Today we are going to see the simulation for radio digital modulation ASK, which is amplitude shifting keying. So, as we explained before, we have two block diagram, which is for the transmitter and also for the receiver. We have a multiplexer here, we have VC here, and we have VM here. So we see at the GNU, we have multiplexer here, we have VC here, and we have VM here. And the key we put is 01101. Next, this one, the upper one, is the part for the transmission. This is the graph we want, the graph we name as modulated, okay, for the transmitter. And the downward one, the downward here is a receiver ASK, which is we have a diode and also modulated signal. We don't have diode in GNU, so we use ABS as a diode, and we also need to put a low pass filter to get the better result. Okay, first of all, we want to see the graph for the input signal. For the input signal, the waveform is like this, without ASK. And then, after we apply ASK here, we transfer the signal being like this one. This is a transfer signal, which have the ASK that we are key 01101, like this before. We key as 01101, right? So 01101. It's because the string of the pulse from the digital signal change the amplitude of the carrier signal. Next, for the receiver part, we have diode and also low pass filter, right? So we don't have diode in GNU, so we use ABS as a diode, and we apply the low pass filter, and we see the result. The result being like this. Also follow the key 01101 off with 0 on this 1. And the exact result, the better result, we display as like this. We can see that we also have 01101 after the ASK. So that is the simulation for the ASK. Okay, one of the implementation of ASK is RFID. RFID, when we touch, we on, which is 1, we don't touch, it's 0. It is off. So it is simple ASK implementation in real world. And the advantage of ASK is, of course, low cost instead of another security device. And it is a simple implementation, short range system, and very power efficient, which is we doesn't need any big power supply. So of course, ASK give benefits to the society. So first, it's making remote control device cheap and accessible. And second, enhance security through FRID system, which is, for example, if we want to go to the office, use RFID to open the door. It's more secure and cheap. Next, enabling low power IoT sensor for smart environments, which is green environment, and reducing cost for communication technology, which is good for our society.
Some people think that ASK radio system like RFID is very harmful because of the radiation, but actually this device operate at very low power, which is typically from 0.01 to 10 milliwatt, far below than safety limits set by WHO, MCMC, and so on. So RFID access card don't even transmit actively like passive RFID tags, only reflect the radio signal using backscatter, which is even weaker than a Wi-Fi signal. So and infrared remotes also use light, not an RF, and are completely safe for human. This device transmits tiny amount of energy, far less than your phone or Wi-Fi. Most RFID cards don't even generate their own signal, so ASK systems are safe to use daily. Second one is safety misconception. Some people say that RFID and gate remotes can cause interference to medical device or aircraft equipment, but actually ASK devices operate in license-free ISM bands and use very low transmission power, have narrow range 1 to 10 meter is maximum, and are strictly limited by international safety standard. They cannot interfere with life critical equipment because the power is too low and frequency are regulated. Metal shielding in hospital also prevent interference. So this short range of ASK devices can use very small power and operate in safe frequency bands. They cannot interfere with medical equipment or airplanes. Third is legal misconception. Like anyone can transmit any ASK signal using any frequency. Like it's all free to use. To correct this understanding, radio waves are regulated by law. For example, in Malaysia, all radios must comply with MCMC regulation. The ASK device must only operate in specific ISM bands such as 433 MHz, 315 MHz, and 2.4 GHz. Transmitting outside this band is illegal and may interfere with emergency services, block license communication, and lead to fines of confiscation of equipment. So ASK is easy to generate, but the frequencies are controlled by the law. You cannot simply transmit on any channel. Only approved ISM bands are allowed. Lastly, environmental misconception. Many people believe that RFID tags or small ASK devices don't affect the environment because they are tiny. But 1 billion of tags are produced every year, they contribute to electronic waste. RFID tags contain small metal antennas, plastic layer, and sometimes silicon chips. The material are hard to recycle when combined, and most end up in landfill. To reduce environmental impact, research are already developing biodegradable RFID tags, paper-based antenna, and low-power backscatter sensors that don't need battery. So environmentally, ASK systems are moving toward more sustainable and eco-friendly design. In summary, ASK technology is actually safe and legal when used in approved frequency band and incredibly used in daily life. But like all electronics, it does produce waste, and modern research is working hard to make RFID and IoT systems greener. By understanding the misconception around health, safety, and legal use and environmental impact, we can appreciate how ASK continues to support safe, smart, and sustainable communication systems.